Last time we were talking about the Hardy-Weinberg equilibrium. We did mention that in a normal population where there is no evolution happening, the population will exhibit the Hardy-Weinberg equilibrium. That means that the frequency of the phenotype or the genotype will match the stuff that we got from the from the calculations. So how do we calculate this equilibrium? So, again, this is a way to know if a population is evolving. The normal way, and that's something you did for the homework, is when we have like a 50-50 frequency for the alleles. So imagine that we got two different alleles. Let's just call it P and Q. All of them got a frequency, in the whole population of 0.5%, sorry, 50%, that means zero point 0.5 here. The exhibit, the result will be 25% for the dominant homozygous, 50% for the heterozygous, and 25% for the recessive homozygous. That's what happened when you did your homework last time. You remember from the second partial that you were doing um, the activity about the Punnett square, you come up with these results. So what happened if we make variation in that frequency? And that's something that you will have to do. Well, first, you have to remember that when you're counting the allele frequency, you will have to do something like this. You will have to be able to add up those two numbers to 100%. If those two numbers don't add up for 100%, well, it means that there may be some allele in there that you are not considered. In that case, well, we can change the amount of alleles. So if instead of two, well, there is three, for example, then we got a different equation that we can say so. So this equation, the most basic one, I mean, you can go and look here for the whole stuff. What they are doing is like multiplications, something like that. But let's just keep it with two alleles only. That's the stuff that you're gonna need for your activity. So this is a calculator that I found and over the internet. You can find whatever you get in there. What is important for your activity, well, is that you show me that you are doing the genotype frequency equation, and well, the result of that. If you want to include a picture of this, that would be nice, or you can write it down. That will be the same for me. So let's just say that you got for your allele frequency, let's just say 0.7 and 0.3%. So this is the result. For your genotype frequency, this must be the result. The most common one, remember this one, this little guy is the homozygous dominant, because that has two of the dominant alleles. This one is the heterozygous. And this one is the recessive homozygous. So for the dominant, for the frequency of the genotype for the dominant homozygous, that must be almost 50%. For the heterozygous, that must be 42%. And for the one that is, the recessive homozygous, that won't reach even the 10%. This is 9% only. Another way to see that, if we are talking about phenotype, the dominant phenotype will be 91%, and the recessive phenotype will be 9%. That's what you have to do for your activity. So, well, I mean, if I put it like this, there is nothing much that I can say, but this one, it will tell you more. So what you have to do for your homework, in this case for the activity, is that you have to tell me that population is evolving. How do we know that? Well, if the results for your calculation match this little calculator, that means that they have reached the Hardy-Weinberg equilibrium. And in that case, well, they are not evolving. Again, they are not evolving if they match the Hardy-Weinberg equilibrium. But if they don't match it, well, they are evolving. So you have to tell me with this proof that they are or they are not matching the Hardy-Weinberg equilibrium. Remember, in this case, we're talking about the, well, if you say that this one is the dominant, the P is the dominant, this one states for the dominant homozygous. This one stands for the heterozygous, and this one is for the the recessive homozygous. So keep in mind that. Good luck with your homework. Hopefully this will be, well, very helpful. Hopefully. Thank you all for paying attention.